So now we're in for some good calculus fun. Suppose that this is a function r of t, so it's going along this path right here. And then we're going to find the tangent vector, the normal vector, and also measure how curvy it is, find out the curvature. So first of all, when you are at this point and you take the derivative, then this would be the tangent vector going in this direction. And we want this to be a length of 1. So the unit tangent vector, thus symbolized by this capital T, will be the derivative. So that makes it the tangent. But we want it to be a length of 1. So then divide by the length of the derivative. That shrinks it down to be a length of 1. Now, normal means perpendicular. So the normal vector is perpendicular to the tangent vector. In order to find the normal vector, that will be very similar to this. That will be the derivative of the tangent vector. And then to make that a unit vector, you divide by its length. And these two will be perpendicular. Okay, now what about the curvature? So the curvature, let's say that something is not very curvy at all. It's like that, just barely any curviness. And then let's say that this is, pretend that that's 1 mile. You're driving along this road and it curves. This is a top view looking down at the road. You're driving along this road and you drive this 1 mile and you curve just a little bit to the right. Now compare that with the next stretch of 1 mile road that's like this. So as you're driving along, the tangent vector would be like this. And then when you get to here, the tangent vector would be like this. So the tangent vector, it changed a little bit as you drove that 1 mile, but not a lot. When you're on this really curvy road, the tangent vector would look like this at this point. By the time you get to here, it's going to be like this. By the time you get here, it's going to be like this. So now the tangent vector is moving around. It's changing a whole bunch. This black curve was 1 mile. This black curve was 1 mile. And yet over this 1 mile, the tangent vector changed a lot more. So the curvature. On the online homework, they use a kappa, a Greek K. It just sort of looks like a cursive K, but just think of it as K for curvature. So the initial definition is, what's the change of the tangent over the change of the distance? Then find the length of all of that. So this is saying, well, how much is this tangent vector changing as you change your distance of 1 mile? Now this is, we don't even have the variable s necessarily. So this is, in theory, it's a good idea, but for actually finding out what's the curvature, we need something else. Well, remember that s is the arc length. So s is equal to the integral of the first derivative. So what happens if you take the derivative of s with respect to t? Because this is a function of t, this is a function of t. So what if you take the derivative with respect to t? Well, if you take the derivative of the integral, they cancel each other out. And you'll get just the length of r prime. So that's what ds dt equals. So for the curvature, what I can do is take the fraction that was already there, and on the top, divide by d lowercase t. Then you need to do the same thing on the bottom, ds dt. Well, ds dt, that's the length of r prime. And then this is saying t prime. So in other words, curvature is equal to the length of t prime over the length of r prime. Okay, now sometimes this is the easiest way to do it. Sometimes it's not. So there's an alternate definition. And that is, for the numerator, you can take the first derivative, cross product the second derivative, and then find the length of that vector, and then divide by the first derivative being cubed. So as I mentioned before, there's times when using vectors and cross products and things like that is easier, and sometimes this way will be easier. All right, now let's actually do some examples. So for example number 1, the function is going to be 3 sine of t, 3 cosine of t, comma 1. If you put x squared plus y squared, that will equal 9 sine squared plus 9 cosine squared. You could factor out the 9, and sine squared plus cosine squared equals 1. So this is a circle. And then it's at a height of 1 on the z-axis. And then this is what the directions look like in the homework. Find capital T, find capital N, and curvature. All right. So capital T, we just need the derivative divided by its length. So first of all, the derivative. The derivative of sine is cosine, so this one is 3 cosine of t. This would be negative 3 sine of t, and the derivative of 1 is 0. Then what's the length of that? So that would be the square root. Square this is 9 cosine squared. Square this middle one will be 9 sine squared, and then plus a 0. So with this, I could factor out the 9. So this is what I was saying without writing it down just a moment ago. And factor out the 9. And then it's going to leave cosine squared plus sine squared. And then this is going to equal 1. So square root of 9 is 3. So that means that the unit tangent vector will be the derivative and then divided by the length of the derivative. So when you divide them, so 3 cosine of t, negative 3 sine of t, comma 0, and then it gets divided by 3. So in other words, the unit tangent vector, you can cancel out the 3's, will be cosine of t, negative sine of t, comma 0. All right, that is the unit tangent vector. And it's a unit vector because if you find the length of this, the length will equal 1. Next up, how about the normal vector? So for the normal vector, you now just take the answer that you just got, find its derivative, and divide by its length. It's sort of it's like the same process over and over again. Just take the derivative again, divide by its length. So t prime will be, the derivative of cosine is negative sine. The derivative here is going to be negative cosine, and then 0. And if you find the length of that, that would be the square root of sine squared plus cosine squared plus 0 squared. And since sine squared plus cosine squared equals 1, this equals 1. So that means that the unit normal vector would be this derivative divided by this length, which means that it's just negative sine of t, negative cosine of t, comma 0. All right, we're done with this. Is that on the screen? And this. Now, as I showed in this beautiful little illustration right here, these two are perpendicular to each other. Well, if they're perpendicular, then you should be able to take the dot product and it will equal 0. So just as a quick check, t dot product with n. So t is right here, n is right here. When you take the dot product, it's going to be this times this, so that's negative sine t times cosine t, plus, now multiply these two, and it's going to be a negative times negative, so that'll be positive sine t times cosine, and then 0 times 0. Well, this is positive sine cosine, this is negative sine cosine, so that means that the dot product equals 0, just like it was supposed to. They are perpendicular to each other. All right, next up, find the curvature. So we can use either one of these formulas. I'm going to try using this one because it looks simpler. So take the length of t prime divided by the length of r prime. Well, actually, I've got the t prime right here. The length of t prime is just 1. I should be able to finish it right over here. The curvature is equal to the length of t prime divided by the length of r prime. And so the length of t prime is right here. The length of r prime is right there. Oh, that's nice. Good job, Greg. You did the work for me already. Thanks, buddy. So the curvature equals 1/3. So as I mentioned before at the beginning, this is a circle of radius 3. And its curvature turns out to be 1/3. So in general, for a circle, the curvature will be 1 divided by the radius. So think about this. If you have a circle and the radius is 2, and then you have a circle and the radius is 10, which one is curvier? Which one has more curvature? One way to think about it is, suppose that you are driving in a go-kart and you're going around a track, and you're going to go 15 miles an hour. Whether you're on this track or this track, doesn't matter. You're going to go 15 miles an hour. So if you're on this track and you're going 15 miles an hour, you're going to have to go round and round and round and round. Which one is going to make you dizzier? To go 15 miles an hour on this one, or to go 15 miles an hour on this one? This one would make you dizzier. Or yet another way to look at it is, if you cut off a piece of this and examine how curved that is, and you cut off a piece of this and you look at how curved that is, this is closer to a straight line than this. This one's curvature is 1/10. This one's curvature is 1/2. This one is curvier. Okay, then on to another example. So for example number 2, how about t, 2t, 3t? You know what kind of shape that makes? That's a line. And how curvy is a line? Lines are not curvy at all, so we should get that the curvature equals 0. All right, let's see. So the first thing we need is the derivative. So that's going to be a 1, 2, 3. That was nice. Now find the length of that. So that'll be the square root of 1 plus 4 plus 9. So that is the square root of 14. All right. And then The unit tangent vector is just those two things divided. So take this and divide by the square root of 14. So you can just do that individually, divide each one by the square root of 14. So there's the unit tangent vector. Now for the normal vector. So for the normal vector, we now need the derivative of this. And that is going to be boring. Just equals 0. And so then what happens to this guy? Because now you have to take the t prime, which was easy to do, but you have to divide by its length. Well, its length would be the square root of 0 squared plus 0 squared plus 0 squared, so that equals 0. So that means that this one, the normal vector, would be 0, 0, 0 divided by 0, which does not exist. N'existe pas. Does not exist. Division by 0 is not possible. What about the curvature? Since it's a line, it should not have very much curvature. So let's use this one. So take the t prime divided by the r prime, the length of each one of those. So the t prime, that one, that's the length of t prime divided by the length of r prime. So the curvature would equal 0 divided by the square root of 14. And that does exist, it equals 0. In other words, a line has no curvature. Okay, that was a quick example right there. Now let's do something a little more challenging. The total curvature. So the total curvature, I was just trying to look for like this one. So the total curvature for a circle, it happens to be a constant. But if you have some other shape, when you find the curvature, you're finding the curvature at one particular point. So as it's passing through that point, how curvy is the curve right there? But if you want to know total curvature, then you need to go from here, so total curvature over an interval. You would need to go from point A to point B. And as I drove from point A to point B, you add up all the curviness. And then how much is that going to be? So the general formula is that you integrate from A to B, and then you would have the curvature. And this would be times the length of the velocity vector, or r prime, and then dt. So that's the given definition for total curvature. But curvature is the length of t prime, the length of t prime divided by the length of r prime. And velocity, that is r prime. Then it's a good time for the red pen to say those two cancel each other out. So it turns out that for total curvature, you integrate the length of the t prime from A to B. All right, now, and then for example number 3, how about if we've got t squared, and 1. So this is basically saying the y value is equal to the x value squared. That means that this is a parabola. It happens to live at a height of 1 on the z-axis, but it's a parabola. So for this one, let's do the curvature and the total curvature. So for the curvature itself, we would need t prime divided by r prime. So t prime, that means we need to first start with the derivative. So the derivative would be 1, 2t, and 0. That was so easy, I think we're going to be done in like a matter of seconds. And then find the length of that. So that would be the square root of 1 squared plus 2t gets squared, and then 0 gets squared. So there we go. So that means that the unit tangent vector is, so you need to have this one divided by this one. So 1 divided by the square root of 1 plus 4t squared. And then 2t gets divided by the square root of 1 plus 4t squared. And the last one is just 0. So there's the t. And now, working on the curvature, the next thing we need to do is take the derivative of that. And then we will find the length of that derivative, and then we'll divide by the length of the original first derivative. But wait, if I need to take the derivative of this, that means I need to do the quotient rule. And the quotient rule, you know what? Instead of complaining, just do it, Greg. All right, here we go. Ready? All right, quotient rule. So that means you're going to have a fraction. You start on the top, the derivative is 0, and then you leave the square root alone. And then it goes minus. Now leave the 1 alone and take the derivative of this square root. So the derivative of a square root is 1 over 2 times the square root. And then don't forget the chain rule. The derivative on the inside is going to be 8t. And for the quotient rule, the bottom gets squared. So that is the first component. Now do the quotient rule over here. Then do all of the algebra to simplify all of this, and this one also, and then find the length of all that. So that's where I'm starting to wonder, is there a different way? Well, a good thing I've got this little formula sheet right here. You can also do the curvature this way. So take the first derivative, the second derivative, do the cross product. Divide by the length of the first derivative cubed. Okay, so I'm going to say start over. So I need the first derivative, and I also need the second derivative. So the derivative of that would be 0, the derivative of that would be 2, and derivative of 0 is 0. Now find the cross product. So put an I, J, K, and then this one goes first, so this one goes first. 1, 2t, and 0. 1, 2, and 0. All right, what's that going to be? So cover this up. That would be 0 minus 0. Now cover up this one. That would be 1 times 0 is 0. 1 times 0 is 0. So that's a 0. And then this would be 2 minus 2t. 2 minus 2t. And now find the length of that vector. So the length of R1 and R double prime is going to be, so it would be 0 squared plus 0 squared plus this squared. Well, because it's a square and a square root, they cancel each other out, so that's just 2 minus 2t. I just realized I made a mistake. This says 0, and right there I wrote a 1. Hey, why didn't you guys tell me? That's okay, I'm not reshooting the video because of that. We can fix that easily. That's a 0, which means when I was doing this part, it would be 2 minus 0. So I can fix that. I've got an eraser right here. 2 minus 0. Oh, so it doesn't even have a 2t in it. It's just a 2. That's it, just a 2. Okay, so we've done the numerator. Now take the length of r prime and cube that. So that's right here, the length of r prime. We just need to cube that. So the curvature is going to equal 2 divided by the length of r prime, and then that part gets cubed. So look at this. We could have kept going with this and do the quotient rule right here, and then simplify it, and then find the length of it, and it would have turned out to be that. Or we could do that little bit of math, as long as we don't make any silly mistakes, and we get the curvature right here. Now for the very last part of it. So like I said, this thing is a parabola. So right here, if you go back to the beginning, and right now I'm just looking at the x-axis and the y-axis, so I'm basically looking straight down the z-axis. And if you do that, then right here, that's the vertex, so that would be 0, 0. Well, to make this 0, 0, that's t equals 0. And then if you plug in a 1, this is going to be 1 and 1. So that would be approximately right here. Okay. So let's find the curvature right there and find the curvature right there. So according to this formula, all you need to do is plug in the t right there. So the curvature is equal to 2 over the square root of 1 plus 0, and that gets cubed. So that is equal to 2. The curvature is 2. Which one do you think is more curvy, right here or right there? I think it's right here because it's going around that curve at the vertex. I think that's curvier, so this should be the bigger number. So at this point, the curvature would be 2 divided by, and then just plug in a 1 for t over here. So that would be 1 plus 4, and then the whole thing gets cubed. So that is 2 divided by the square root of 5, and it gets cubed. So that is a 0.179. So right here, it's not very curvy at all. And finally, for the last part, and on the homework, I think it's the last 2 questions that ask you for the total curvature. You like how I spell curvature? The total curvature, so that's where you need to integrate. That's where you need to integrate from a to b, and we're going to use 0 to 1, the length of t prime. So it's going to be, oh, you know what? We didn't find t prime because it was all this. So we never even did that part. So that means we're going to have to go back and do this. Integrate the curvature times the length of the velocity. So it'll be integral from 0 to 1, and then it's the curvature, which is right here, times, this is the velocity, the first derivative, the length of it is that right there. So you need to multiply by the square root of 1 plus 4t squared. So this says it's got 3 of them right there. This has 1 of them. So that means that, hold on, it's a job for the red pen, that one of these square roots can cancel one of these, but there would still be 2 down there. Which means this square and that square root cancel each other out. And then we need to integrate. Do you know what the antiderivative is? It's going to be tangent inverse. So you could use u substitution, let u equal 2t. Because the way that I'm viewing this one, what my brain says is you've got 1 plus a 2t being squared. Because that way, 1 plus something squared in the denominator, that's probably tangent inverse. So then the derivative of that would be 2 dt, and there's 2 dt sitting right there, so you can make the u substitution. So it's going to be, the top just becomes du, and the bottom becomes 1 plus u squared. So sure enough, that's tangent inverse. And then I'm going to resubstitute in place of u, that would be 2t. And then evaluate from 0 to 1. So this will be tangent inverse of 2 minus tangent inverse of 0. So tangent inverse of 0 is 0. Tangent inverse of 2, I do not have that one memorized. In radians? Tangent inverse of 2, so it's 1.107, because tangent inverse of 0 is 0, so that part doesn't count. So there's the total curvature, 1.107.